Hello class, in this video I'll be showing you how to use the Fundamental Theorem of Calculus to find the value of a definite integral. Let's begin. So we want to evaluate this definite integral from 0 to 4 of this function that I'm highlighting in yellow. And before I talk about the continuity of this function, I want to rewrite this definite integral using property 5 of definite integrals. So we have the definite integral from 0 to 4 of this function here. And if I take the opposite of this function, which means going from negative to positive, we have to reverse the order of the limits of integration. So this is equal to the definite integral from 4 to 0 of the opposite of the original function. Now you don't have to do this, it just makes it easier to work with when we apply the Fundamental Theorem of Calculus. Okay, so now that we have that, we want to answer the question, is f of x continuous on the closed interval 0 to 4? And the answer to that question is yes, because f of x is the sum of two square root expressions. And you could take the square root of all positive numbers, and you could take the square root of 0. So that means the graph of f of x is not going to have any holes or jumps or gaps. It is going to be continuous. And now that we know that, we can apply the Fundamental Theorem of Calculus to evaluate the definite integral. So we have lowercase f of x is equal to this, and that implies that an antiderivative is this function here. All right, so here we go. The definite integral from 4 to 0 of f of x is equal to an antiderivative evaluated from 0 to 4, and then we're going to subtract the results. All right, so let's evaluate the antiderivative at 0. And that's just going to be 0. Next, we're going to evaluate the antiderivative at 4, and that will look like this. And since 4 is a perfect square, you can evaluate this expression in Decimus and get an exact answer. So that is going to be negative 656, or positive 656/15. So the antiderivative evaluated at 0 minus the antiderivative evaluated at 4 is equal to the following. Negative 656/15. Okay, so that means that the definite integral from 0 to 4 of the original function is negative 656/15. And what does this value represent? All right, well, I've sketched the graph of f of x, and notice that the graph is completely below the x-axis, which means all the area that I've shaded in red has a negative value. Notice that at no point the graph goes above the x-axis. So there is no point in this graph where the area is going to be positive. So if I take the area in green, which is 0, and I add it to the area in red, which is negative 656 fifteenths, the result is negative 656 fifteenths. And that's what the value of the definite integral represents. And we are done.